So we got a next one. Then our next one, the medium blue, I guess I'll call that. It says let g of x equal this. On which intervals is g increasing? Okay, I'm going to introduce to you guys a sine line graph. I like this sine line graph because it helps us visualize a lot of things in the future. Okay, this is actually just the x-axis. Okay, the sine line graph is. And on this x-axis, I'm going to put the critical values. So to find our critical values, we have to find where g prime is undefined, like does not exist, where it doesn't exist, or where it equals 0. So first we need g prime. So I'm going to take the derivative of g, and I get negative 3x squared plus 8x minus 5. So I'm setting this sucker equal to 0. Now, I know this is a polynomial. It's a parabola, actually, and there are no points on this parabola where we will be undefined or does not exist. So we don't have to worry about the D and E stuff. We just have to find out where this guy equals 0. Unfortunately, we can't make our leading coefficient equal to positive 1. Otherwise, I would love to do that. Instead, what I'm going to do is I'm going to use my big X. Not everybody uses the big X, but I do. Negative 3 times negative 5 is 15, so I'm going to put 15 up there. And then I put 8 on the bottom. What times what gives me positive 15, then adds to 8. Sounds good. So now I'm going to take this middle term, and I'm going to split them up with the 3 and 5 to get negative 3x squared plus 3x plus 5x minus 5. This equals 0. And I'm going to factor this by using grouping. When I do that, I group the first two terms, and I group the last two terms, and I take out a common factor. I can take out negative 3 from this one, negative 3x, and then I get x minus 1. And over here, I could take out the greatest common factor. That's going to be positive 5, and I get x minus 1. And that's exactly what we wanted. We wanted a common factor that we could take out of both of those terms. That's this term and this term. And we could take out an x minus 1. After we take out the x minus 1, we're left with negative 3x plus 5. And then I take each of those factors and set it equal to 0. And since you guys are way past Algebra 1, we can do this in our head. X equals positive 1 and x equals negative positive 5 over 3. Which on the graph would be 1 2/3. Okay, so I'm coming up to my sine line graph. That's what I like to call it. And I'm going to put 1 right here, and I'm going to put 1 2/3 right here. Now, if you want to find out where g is increasing, you have to find out where g prime is positive. Where is g prime positive? And you have to check number over here in this interval and this interval. Okay, and what we're going to do is we're going to make a sine line graph for, not f prime, g prime. Okay, so are the y values in this interval, which is negative infinity to 1, are these g prime values going to be positive or negative? And are these g prime values going to be positive or negative? And are these g prime values going to be positive or negative? You see, there's a word. It's a really complicated word. It's called monotonicity. And monotonicity says that all of the g prime values in this interval will be the same. And all the g prime values in this interval will be the same. And all the g prime values in this interval will be the same. But in order to test, we need to have numbers. And so I always try to pick the easiest numbers that I can. For this one, I'm going to pick 0. For this next interval, this one's not going to be pretty. I'm going to pick 1 1/3. Or we can say, that'd be 4 over 3. It's not pretty. I don't like that one. And then let's pick a pretty one over here. We'll say 2. Okay. The lowest, or 0. Just pick pretty ones. And so we're going to have to plug these into the g prime function. So if I take 0 and plug it in, most of the time we could do this in our head. In fact, I think I could totally do this one in my head. 0 to the third is 0. 4 times 0 is 0. 5. Wait. This is not g prime. Stupid. It's right here. Okay, so this one's 0. This one's 0. Then I minus 5. What do I get? Negative 5. Okay, so this one's negative. All right, and this is bugging me right here. No. Okay, now let's try 4/3. Okay, so now I'm going to try 4/3. Now we don't need the number. We just need to know what the sign of the number is. We're going to try 4/3. What does that look like? Now I'm going to write it out. Usually I would try to do this in my head, but I'm going to write it out just so you guys are seeing what's going on in my cabeza. All right, So we have plus 8 and then 4 over 3. And then we have minus 5. Now, because there's fractions, maybe I would write it out. I don't know. See, this would be 16 over 9. And if I multiply this number times this number, I will get a negative number, right? Right? And then I also have a negative number over here with the negative 5. And if I multiply these two, I will get a positive number. That would be 4 times 8 would be, what is that, 32? 32 over 3. All right. So I get a positive number and 2 negatives. I'm not quite sure if there's more negatives than positives, and so I think I have to take this a little farther. Let's see. We squared that. Let's go. 3 times 16. What is 3 times 16?
Well, you could do negative 3 divided by 9, right?
Oh, yeah. Let's cross cancel. I like that. So we multiply by 3, and that's going to be 3. And so
Negative.
what is this negative number going to be? It's going to be negative 5 and 1/3, right? Okay, and this number is going to be 10 and 2/3. And then we have negative 5 right here. Which number is going to come out on top, the positives or the negatives?
The negative, right?
Let's see. Yeah, totally, because there's... No, positives. Positive will.
Because that's 5 plus
Yeah,
5
so
and 1/3.
we're going to be positive.
1/3 versus 10 and 2/3.
So I put a positive right here. Now, chances are, I mean, a lot of times the sign changes, but sometimes the sign doesn't change. But let's plug in 2 in our head, okay? 2 to the 4th power is 4 times 3 is negative 12. Actually, I want to write that down because I don't want to do too much math in my head. Okay, so I get negative... Did I do that wrong? No, it's negative 12. And then I have a positive 16 and a negative 5. All right. Do positives or negatives win here? Negatives win. And so this is negative. And so our final answer is, wow, that took a long time. Where is it increasing? From 1 to 1 2/3.